Welcome back. We are going to be doing the same thing we did previously, but now with our square root function. So starting with our parent function, if I want to get a few points on the graph and connect the dots, what's going to be most helpful here is finding perfect squares so that I can get whole numbers. So I'm going to start with 0. The square root of 0 is 0. Then I'm going to go to 1. The square root of 1 is 1. The next perfect square I have is 4. The square root of 4 is 2. And then the last one that's going to be able to fit on this grid is 9, the square root of 9 being 3. So I've got those points that I can connect, and see I've got this upward curve looking graph, and its domain, its x values, start at 0 and go positive, so x is going to be greater than or equal to 0. If you like interval notation, you can write it that way as well. Our range, our y values also start at 0 and go up positively forever, so y is also greater than or equal to 0. We do have a minimum because it stops here, so that minimum y value is 0. We don't have a maximum because it's going on forever. Our x-intercept is at the origin 0, 0, which means our y-intercept is also 0, 0. We don't have an asymptote. That's not a feature for a square root function. And it is also not going to be symmetric. There is nowhere we can fold it or rotate it that it will line up with itself. And then increasing from the very start, it walks up, we would be walking uphill and we never turn back around. So it's never going to be decreasing, and it's going to be increasing from 0 till infinity. Okay, we are going to look at some transformations now. The formatting is the same as far as your vertical, horizontal dilations, vertical and horizontal shifts, and your reflections. So jumping into this first equation here, that 7 on the outside tells me it's a vertical dilation, and that is going to be by a factor of 7. And then the minus 8 on the outside tells me that this is a vertical shift down, so we are going down 8. On the next one, I have a negative on the outside. That negative on the outside tells me it's a reflection over the x-axis. And then the minus 6 on the inside tells me that this is a horizontal shift to the right. And then the last one, the negative on the inside, tells me that we are reflecting over the y-axis. And then the plus 4 on the outside tells me that we are going up 4. Okay. Now, just like we did on the previous one, I'm going to put those 3 transformed functions into Desmos, and we are going to look at how those features change. Okay, so here I have Desmos with our original square root parent function already graphed. And now I'm going to put in our first transformed function, which is 7 square root of x minus 8. And we are going to look at that blue graph. I can zoom out a little bit so you can see that dilation really stretches up and makes it super tall. So my x values still start at 0 and go off to positive infinity, so x is still greater than or equal to 0. But my y values now start down here at negative 8 and go off to positive infinity, so y is greater than or equal to negative 8. We do still have a stopping point here, so my minimum y value is going to be negative 8, and we have no maximum. Our x-intercept, I'm going to have to look at the graph to tell me, that is at 1.360, and my y-intercept is down here at 0, negative 8. Still no asymptote, no axis of symmetry, and we are still increasing, starting at 0 and going until infinity. And it never switches back to decreasing, or it never switches back around to become decreasing. Okay, I'm going to move on to the next one and change that blue graph to reflect our new one, negative x square root of x minus 6. Okay, so this one looks a little bit different now. Our x values have shifted. They now start at 6 and go to positive infinity. So x is now greater than or equal to 6. Our range, our y values start at 0, but they go into the negatives. So y is going to be less than or equal to 0. And now this is my stopping point, but this is now a maximum y value at 0, and there is no minimum. And that's also where I have my x-intercept there at 6, 0. And the graph stops here. It does not keep going to the left, which means it's never going to cross my y-axis. So it does not have a y-intercept. Still no asymptote or axis of symmetry. And then where my graph starts, if I were to be walking along it, I would be going downhill, which means we are decreasing from 6 to infinity, and it's never going to switch to increasing. Okay, we are going to look at one last graph here. So moving that negative inside, and then +4. Okay. Looking at the blue graph again, our domain, our x values start at 0, but they go into the negatives. So x is going to be less than or equal to 0. And then our range, our y values start at 4 and go up positively. So y is going to be greater than or equal to 4. Which means this is also now going to be a minimum y value again at 4. We have no maximum. And then my graph stops here. It does not keep going to the right, which means it's never going to cross my x-axis. So we have no x-intercepts. But we can see right there the y-intercept is at 0, 4. Still no asymptote or axis of symmetry. And as I'm going from left to right on this graph, I'm walking downhill until the graph stops. So we are never going to switch to increasing, and we are decreasing from negative infinity to 0. Okay, that concludes our square root key features and transformations and our today's notes.